Welcome back, Calc. So we are going to be looking at finding absolute extrema by hand today. I have the checklist on the screen. You know what to do from here. All right, so I'm going to force a pause on your screen. You don't need to write anything yet. Just kind of in your head, decide what the strategy is. And what I mean by that is which derivative do we analyze, first or second, for each of these three scenarios. So go ahead and decide and then hit continue when you're ready to see the answers. So the only time we analyze the sign of the second derivative is when we are looking at where f is concave up or down. But when I want to know where f is increasing, decreasing, or where f has a relative extrema, then I would look at the first derivative. And today we're going to look at absolute extrema, so once again we are going to be looking at the first derivative. Alright, so the absolute extrema is where is your absolute highest and absolute lowest point or y value on your graph. Okay, so the extreme value theorem says that if f is continuous on a closed interval, then we are guaranteed both an absolute min and an absolute max. So let's write this in hypothesis conclusion form. So EVT, extreme value theorem, says, write this for me, that the hypothesis is if f is continuous on a closed interval. And what I mean by that is your endpoints are included, okay? So you're not going to have open circles at the end. You'll actually include your endpoints, okay? So if f is continuous, does not need to be differentiable, but it does need to be continuous on a closed interval, then f has both a max and a min on that interval, okay? So make sure you've got that written. And then decide, again, you don't need to draw these graphs, but let's take a look at these graphs and decide yes or no, is the hypothesis met and is the conclusion met, okay? So take a look if you want to write just H or C for each one, and then hit continue when you're ready to see the answers. Actually, go ahead and pause because I don't want the screen to be too big here. Okay, so answers are on the screen now. So we only had two, this one and this one, where the hypothesis was met. And if the hypothesis is met, the conclusion has to be met as well, right? Otherwise, we've broken the theorem. Now, if your hypothesis is not met, you can see your conclusion may or may not be met. We don't know. We don't have a theorem for that scenario, okay? So it could go either way there. For example, if I take a look at this one here, the hypothesis was broken. It was not continuous. The conclusion was still met because I do have an absolute lowest and an absolute highest value, okay? But we're going to be looking at the scenario where the hypothesis is met, so I'm looking at continuous functions on closed intervals. So let's take a closer look at the two graphs from earlier where the hypothesis was met. And now let's look at our absolute lowest and absolute highest, or absolute extrema, okay? So for this first one, my absolute min occurs right there, and my absolute max occurs right here. Well, my absolute min, is it also a relative min? Yeah. And my absolute max occurs where? At an endpoint, right? Let's take a look at the second graph, this blue one here. My absolute min occurs right there, which is a what? That's an endpoint. Again, you don't need to write any of this yet. And my absolute max occurs right there, which that is also, by the way, a what? A relative max. Okay, so this is fundamental to our strategy for today, is that our absolute extrema can only occur two places, either at a relative extrema or at one of the endpoints. And remember, I'm only going to be dealing with functions that correspond to EVT, where I'm looking at a closed interval, okay? So I only have to check these places where I either have a relative min or max or at an endpoint. Okay, so let's write our strategy together. Remember, absolute extrema can only occur at, please write this, relative extrema or endpoints. And remember, our relative extrema is what we found for the last lesson. Relative extrema can only occur at critical points. Okay, just because you have a critical point doesn't mean you have to have a relative extrema, but that's our only option, okay? So to find absolute extrema, our absolute highest and our absolute lowest on f, so again, f is going to be continuous on a closed interval, then here's our three-step strategy. So step one is we're going to find our critical points. And remember, critical point is where f prime is 0 or d and e. Let's call those x equals c, d. Okay, you may have 1, you may have 2, you may have 0. You could have any number. Okay, and then step 2 is actually going to be to make not a number line, but a table. So, and our table is going to look like this. We're going to label it x and f of x, the original. In x, we're going to put our endpoints, a and b, as well as any of our critical points, okay? So if I had 2, I'm going to put those 2. If I had 1, I'm just going to put that 1. And it is important to note the critical points should be in our interval, right? If they're not, we can toss them. And then we're just going to fill in the table. So now we're going to plug in, this is important, make a star there. We're plugging in this time to our original function. It's the only time we go and plug into our original function, okay? And then we just pick the largest. F of x is going to be my absolute max, and smallest f of x will be my absolute min, right? Because we said those are our only possible locations. So this is called the candidate test. So we pick all the feasible candidates, evaluate them at only those spots, and then we just pick our largest and our smallest from there. All right, so will you write example 1 for me? We've got f of x equals 3x to the 4th minus 4x cubed on the closed interval -1 to 2. We want to find the absolute extrema here. So step 1, find the critical point. So am I looking at first derivative or second? We're looking at first. So go ahead and find that and hit continue when you've got it. Now we want to find our critical point. So we want to know where this is 0 or d and e. This is not a fraction, so it's never going to be d and e, so set this equal to 0 for me and hit continue when you've got those answers. So I'm getting 0 and 1 for my critical points. Are both of those critical points in our interval? They are, right, which is kind of bad news, because if it's not, we can always toss. We can toss anything that's not in our interval. I'm only looking at that. Okay, so we did step 1. We found our critical points. Step 2 is going to be to make a table, and we are labeling this table x and what? F of x for absolute extrema, okay? Because I want to check what's my absolute highest and lowest on f of x. All right, so I'm going to make a table. I like to go in order, but it really doesn't matter. So endpoints and critical points go in our table. So here are your endpoints, and then I do also need to include my critical points. And now we just plug those numbers in to the original function. So go ahead and evaluate those for me. Hit continue when you've got them. So here's our table. So now we're going to pick the smallest y value, which was -1, right? So here is our absolute min of -1 and occurs at x equals 1. And then pick your largest y value, that's your 16, and it occurs at 2. So I have my absolute min is 1, -1, and absolute max is 16, and it occurs at x equals 2. So here's the graph of the original y equals f of x on that interval -1 to 2, and you can see here that yes, indeed, my absolute min on that interval occurred at 1, and the y value is -1 there, and then my absolute max here is 16, occurred at x equals 2. So let's try that same strategy. Let's try to find our absolute extrema for g of t here. So I've got 4 square roots of t. The first thing I'd want to do here is what? I want to rewrite as 4t to the 1/2, right, because of the square root. So if I find the first derivative here, 4 times 1/2 is 2. This becomes t to the -1/2. So the negative brings that t to the denominator, and the 1/2 is still the square root. So another way to think of this is 2 over square root of t. All right, so this will never be 0 because the numerator is always 2, but it could be undefined when the denominator is 0 In other words, when t is 0, right? But look, I already had 0 as an endpoint, right? So I didn't create any additional critical points, okay? So I'm done with step 1. Now step 2, I need to make a table. And for that, I'm going to label x, well, actually, we'll do t. And what here? G of t, okay? So include your endpoints, 0 and 16. I don't have any additional critical points I need to check, which means that this function must always be on its interval increasing or decreasing, okay? So if I find g of 0, plugging in there, I get 4 times 0, so that's 0. Plugging in 16, I get 4 times the square root of 16, moving back to 16, okay? So I've got absolute min of 0 at x equals 0, and absolute max value of 16 at x equals 16. Okay, you all, that is what I have for you today. We will do number 71 from the assignment together in class, and I will post that for my virtual students as well. Okay, I'll see you all next time.